discussed last week. We'll do the some not theoretical configuration part today. Okay. And let's enjoy configuration. So we'll try to configure GRE over IPsec and VRF. Okay.
Okay.
So let me quickly start with GRE over IPsec, then we'll go with the VRF. Okay. So this is a simple topology. This is the R1 and R2. They are connected over the internet. Okay.
Yeah.
So I have a simple very topology. So if you go on this topology, I just did basic configuration for your understanding. So like we did last time, you remember? So in this 23 subnet is configured on this block. This is 23.
Okay.
Let me configure 23.0.0.2/24, I believe, if I'm not wrong. What is the IP I configured? So run interface. So it's 24. So let me weightage. Let me make it 8. Make it bold. Then okay.
So this one I'm able to open too. I will be able to open.
Yeah, you can open. No issue. Let me. Where is the size? How can I increase the size? Okay, so let's 23 is here. And let me create duplicate one. So here might be 3. So this IP would be 3, this IP would be 2. And for here we having, come on. What happened? I don't know what happened. Let me take it. Duplicate section. Okay. So this would be just 12.2, and this would be 12.1. So this is the IP allocation. Okay. And it's pretty simple. So from here to here, we having reachability from this router. If I want to ping this 23.3, it is reachable. So let me try to ping that. So 23.0.0.3, it is pingable. So, and from R3 to R1, let me try 12.1. It is pingable or not. Ping, this is this. So let's suppose these are the public addresses and they are reachable to each other. So this is the prerequisite in the IPsec tunnel. The site from which to which we are going to create IPsec tunnel, that public address should be reachable, right?
Yeah.
So that is a prerequisite. So we are created here now and it is reachable. Okay. So next move to next section. So we have to understand what is the IPsec and what is the GRE. So GRE, as you know that generic routing encapsulation, that basically what we called that we having a tunnel, but that is not secure tunnel. So whatever data we are sending as GRE, that is not secure. Can anyone hack and can see that all? But the advantage with this GRE is that can send any kind of traffic, either for the unicast, multicast, whatever traffic you want to send, that can be sent over the GRE. Okay, but that is not secure. So this is the beauty of the GRE. But if you talk about the IPsec, so IPsec, sorry, it is not. So IPsec is quite secure, and nobody can see the traffic. It is encrypted from end to end. But the problem is, it is only can send the traffic is unicast, not like if you want to send the traffic a broadcast, multicast, or some other type of traffic that cannot be sent over the IPsec.
Through the IPsec is only
Yeah,
unicast, right?
unicast. So
Mm-hmm.
this is the major difference. So GRE, you can see all that, you can send and receive all the kind of the traffic, but in multicast, you can in IPsec, you can just simply what we can say go with the unicast only. So this is the difference between the IPsec and GRE. But when we club together GRE plus IPsec, it solve our purpose. So the tunnel is secure, right? Plus all type of traffic we can send with the help of the GRE, and we can provide the security with the help of the IPsec. So our
Mm-hmm.
purpose is solved. That's why you use the GRE over IPsec in a tunneling scenario. So is it clear for you?
Yeah.
It's pretty straightforward. So I'm not putting too much, effort in it. So hope you understand. So that is basic difference between GRE and IPsec. So in this lab, we are going to create GRE over IPsec. So what we have to do on this router, sorry, on this router R1, we have to create one tunnel. Okay, that 101, and this router also we have to create tunnel that is 101. So first
Mm-hmm.
we'll create a tunnel that is a GRE tunnel, and we make them reachable to each other. So this is the first lab we are going to do. Then after once we create the GRE tunnel, we create the IPsec configuration and we'll apply over the tunnel. So we'll protect the tunnel with the help of the IPsec, and we'll see how the communication is going to be happen from one source to another source. And for testing purpose, what we are going to use, we will use this loopback addresses. You can see that.
Mm-hmm.
So that from you can just consider these are the LAN interfaces on the router, and also we having a LAN interface. So we can initiate the traffic from this, and it will go for the GRE tunnel, and it will reach to that router.
Mm-hmm.
Similarly, from this loopback as a source, it will go to the traffic on the GRE tunnel, and it will land to this router. So we'll do the testing with the LAN to LAN. Clear for you?
Yeah.
Right. So let's do the configuration. So I'll go in the configuration mode on the router. I'll create the interface tunnel 101. I'll make no interface tunnel 10. Let me make interface tunnel 101, and I'll define IP address 172.16.10.1. Okay, 255 to 55.0. That's all. Okay.
Okay.
All right. So till now, what I have defined, you have to understand. These are the very important thing. So I just defined the IP address. Okay. What next? I go in the interface again, and I have to define tunnel source. So what would be my tunnel source? In this case, this IP address. Okay.
Physical.
Yeah, physical, whatever the
Yeah.
physical interface IP you assign that. So we can see tunnel interface, and there is the option. We can define the IP address. Okay. Or we can define that the interface. So if I go and define the interface, I can define the interface also. So let me define here the IP address. So my tunnel source will be 12.0.0.1. Clear?
Mm-hmm.
And what could be my tunnel destination? That with the another end public IP address, that is 23.0.0.3. That is reachable. So the prerequisite was my both end public destinations should be reachable from ISP. Okay. So that is, we are meeting that prerequisite. So tunnel destination, I'll define that 23.0.0.3. That's all. So if you go, so run interface tunnel 101. So you can see this is the configuration we have made. Okay.
Yeah.
While doing the configuration on a tunnel, we have to understand MTU and TCP MSS. You have heard about that?
Yeah, MTU maximum transmission unit. So it describes how much you can transmit without fragmenting.
Yes.
TCP MSS, and I'm not sure actually what is that.
Yes. Let me explain you that part you have to understand. So when we talk about the Ethernet frame, Ethernet interface, so by default in Cisco router and switches, every Ethernet interface having a maximum transmission unit MTU is 1500 by default, 1500 bytes. Okay. So let me show you. So right now I'm stopping this configuration on here only. After this explanation, we'll go for the next step. Okay. So if I'll go on this interface and if I'll check that, you see that we having a default MTU where it is, see that 1500 byte. That means this Ethernet can receive and transmit maximum size of the packet, that is 1500. Okay.
Yeah. But
so
it's total packet with all layers, or
yeah,
this
so
is
I'm incoming. So it is complete packet, including the layer 2, layer 3, GRE header, layer 4 header, whatever header you are going to include, that should not go beyond the 1500. That is for the Ethernet. Okay. So that is one thing. So when we talk about that, this packet size, so MTU size, so we must know that when we talk about, so like IP header, we have how much? IP header is 20 byte.
20 byte.
Okay, that is the IP header we have, right? And if we are going to do some ICMP ping, that again add a header for the 8 byte. Okay, and if we are running the GRE, that again add a header of the 4 byte. So how much total is overhead? 20 plus 8 plus 4, it's 32 bytes. So if we remove 1500 minus 32, so that my packet will become, I believe, how much it will?
68.
68, right? Yeah, 4. It will become a. Let me try it. 1468. So basically, my PC, if I want to just do the ping with the help of the GRE packet or with the IP header, so my original packet should initiated with the 1468. Then the header can be added. Then packet my packet can be passed over the Ethernet frame. After including this all headers, it will become a 1500 bytes. Makes sense? Then my packet can be passed. So that is one thing. Clear for you?
Yeah, I just wasn't aware that ICMP ping is like need extra bytes if you want to do it ping, or what is that actually, ICMP ping?
So if you just want to perform the ping test, it will also add the 8-bit extra byte overhead.
Okay, and if I'm like, if we're not describing those 8 bytes and we want to do ping, then what happens? Then it's fragmenting?
Yes, definitely. Because if you set the packet, suppose you just add 8 byte, add more, okay, here. So it will be 1476 byte, okay. When you initiating this packet, when you initiating the ping, okay, and this is not initiated, then your packet size will be increased after adding the overhead and GRE tunnel. So that packet will be fragmented again, because it maximum can transmit 1500, right? So that is all about MTU. So after including all the parameters, whatever the overhead you are going to inject from the LAN side, that cannot be exceed more than 1500 MTU size, right?
Mhm.
So that is a one side of the story. Now that MTU is the maximum transmission unit. Now we talk about the IP MTU. Have you heard about that IP MTU?
No, not sure.
So MTU is the layer 2 that work on the Ethernet frame. IP MTU is the layer 3 that's work on the IP. And in this IP MTU, we just do the adjustment of IP TCP MSS, maximum segment size. So there is two things. When TCP packets originate from the actual user machine, they encapsulate that packet with a TCP 20 bytes. They add IP header also, that is again 20 bytes. That ICMP also added, that again how 8 bytes. And then if you are running the GRE, then again add a 4 bytes. Okay. So these are the like predefined packet size where that can be added over the one of the TCP packet generated from the user machine as a overhead. So we have to adjust our TCP MSS size like that. After adding these all overhead, my size cannot exceed more than a 1500. Anyhow, so the concept is anyhow, if you are talking about the layer 3 or layer 2 MTU definition, that packet should not go beyond the 1500 bytes. By
But
adding,
previously you said that it's ICMP included and IP uh,
yeah,
20
that,
bytes. So previously about we also included the MTU, isn't it?
yeah, we included in MTU that also, like, but I'm trying to say in TCP so already we included that this header, and this header. So this is not going to include here. We are talking about TCP header now, okay? Which
Mhm,
is new
mhm.
one actually originating from the packet. But I'm talking about the overhead, all header in the total packet. That is one thing. You understand? Or shall I repeat again?
Well, yeah, a little bit more clarification because
Yeah,
TCP then is a layer 4, is not layer 3.
yes, yeah. TCP is layer 4. So in MTU, we just add IP header. Like in MTU, when you talk about the maximum transmission you're doing, so how
Mhm,
packet will be formed? Packet is equal to maximum 1500, right? Bytes. And what
mhm,
it includes? The original packet plus overhead, right? And what comes in the overhead? That is IP plus ICMP plus GRE. These three overhead head we are talking right now. Okay, when we are talking about the plain MTU packets,
okay.
when L3 packet we are talking, but when we are talking about the TCP packet again from the TCP connection, then we are going to add additional header, that is a TCP header, right?
Mhm,
So that again decrease the size of the packet. So earlier, suppose it was a 1460. After adding the TCP 20, if decrease that minus 20, so it will become a that 1448, right?
yeah,
Makes sense.
yeah, yeah. Mhm.
So in
So
GRE, yeah,
yeah, so we need to always count that
overhead,
basically
all
yeah,
overhead.
overhead, yeah, but MTU is not enough to calculate because it's we still all the time have TCP or UDP sessions,
Hmm.
TCP session, right? So it's not enough to calculate MTU. But why then we talking about MTU at all if we still um, need to minus TCP? So it's
We are just talking here L2 frame transmission. L2 maximum segment transmission on the Ethernet interface that
But
can transmit the, but this MTU, how basically it's calculated, these on this calculation, below calculation, TCP, IP, ICMP tunnels, overheads, that basically generate from the PC where user is sitting. So once user initiated any TCP session, basically user will do the TCP session, browsing, whatever. So that packet will initiate from the this PC as a source destination and then payload. Agree?
Mhm.
And that when packet will build here, then we have to adjust where this packet is coming on this interface of the router or switch device. They cannot basically allow something like already if you are allowing 1500 MTU on this interface, let me
Mhm.
clear. So suppose this is your switch, okay, this is your PC connected, okay, and somehow you just allowing 1500 MTU on this interface, right?
Mhm.
But PC is sending like packets. Let's say suppose it's sending 480 byte packet, default plain raw packet. Okay, TCP packet. So
Mhm.
this packet will what add? It will add the IP header. It will add the suppose you are running a GRE header. It will
Mhm.
add the TCP header. If you are doing the ping, that will add the ICMP header. So
Mhm.
20 and it will be 4.
Or
It will be 20 and it will again 8, right? So how much?
mhm.
20, it's a 40 and plus 12.
Or
So it
52.
will be
52.
52 plus 480. How much total would be? So it will
Yeah,
become
more.
32 bytes.
Mhm.
So what this interface is going to do, they will fragment this packet because they're not going to accept this complete byte packet, right?
Okay.
So after doing a fragmentation, there will be issue,
Yeah.
performance issue, might be some issue. So this is the logic. So we have to understand like how the TCP segment can be basically set in behind the LAN, right?
Yeah. Okay. Um, and then we need to put actually configurations to reduce the packet
Yeah,
size,
yeah,
or
yeah,
yeah. And
yeah.
another question is if we have a switch and router, so MTU we need to describe on switch and another one MSS on router, because if switch is only L2, right?
Mm.
So
We can't do that.
our
Yeah, we can't do that. IP TCP MSS adjust.
we cannot or can?
We cannot on switch because it's L2, right?
Yeah, so if it's L2, so then we just focus on MTU.
Yeah.
Okay, yeah.
So here we on tunnel, because this is GRE tunnel, so it's going to anyhow increase that overhead. Okay. Do show run interface tunnel 101. So we have to go in this tunnel and we have to define the MTU. So we have to define the minimum MTU so that fragmentation can be avoided after adding the all type of payload. So there's two things like we have to define in this tunnel. So one is the MTU, what we discussed right now, and another is like TCP MSS. So let me just go that. So let me IP, let me check MTU. We have option or IP. What command was there? Adjust. What command? I forgot that. There is one command. TCP MTU domain that tunnel. There should be option to defining this MTU and all. Tunnel, okay. Tunnel, okay. Not tunnel mode. Tunnel path MTU discovery not. This is not command. What we call There is a command. I forgot that command. Are you able to recall? IPM.
I'm checking in the Google now. Maybe gonna.
Oh, no. IPMTU. Yeah, IPMTU. We can go here, and
Okay.
then we can
Yeah.
define. Let's suppose 1460, and then TCP adjust MSS IP TCP. What command that? Yeah, adjust MSS. Yeah. So this should be always lowered. So suppose we define the IPMT 1460. It's still, I believe, a higher end. I'll just lower down. I'll just make there's a 1360. That is a standard one. And let me lower down this also. That 420, 1420.
Okay.
So now I go on tunnel interface 101, and we made this configuration. Okay. So you can see that we just we define the IPMTU that 1420 IP TCP adjust MSS. So we adjusted the packet of the TCP that originate from 1360, and after adding these all over it, that cannot go beyond of the 1500. So that's why we added here. All right. So we done with the configuration for this end. Quickly, let me go on the another end and let me do this configuration as well. So I'll go on this way, and I'll just let me create. Okay, let me interface tunnel 101 IP address. Okay, this one not IP address.
Yeah.
116.10.2, 255, 255, 255.0. Then tunnel source would be 2323.3. Tunnel destination would be 130.0.1. IP MTU 1420. Okay.
They
IP.
need to match or not? If
Yeah.
you put different, what's gonna like if still traffic
Yeah,
gonna go?
it will route the traffic because the packet will from this side land. It will assemble the packet on this MTU, whatever configured from this site. Okay, and it will assemble the packet from this side. So they are not creating any problem from here for IPMTU. They are going to form, but they are not going to exceed more than 1500. Okay, but always recommended to put the same. Okay.
Yeah.
So I believe do so run interface tunnel 101. So we have done the configuration. Let me ping the another internal IP address 172.16.10.1. See, it's pingable. So after creating this tunnel, let me see the interface. Tunnel is up. You can see that this tunnel is up. And if I'll go and this also. So
But it's like this tunnel is like a loopback tunnel. You just turn it on and it's up, right?
no, it up because we done the right configuration, because we define the you can see that source and destination. That's why it's up, not a loopback. We
Okay.
have done a lot
Yeah.
of configuration. So let me tell you. So now what I can do, I will route this traffic from here. So suppose if I am sitting on this router and I want to go 3.3.3, I will send this traffic via tunnel. We'll see that. Okay. So IP route 33.33.33 255.255.255, and next hop I'll put that tunnel 101 and the IP address. So next hop IP address of tunnel would be that 2, right? Clear? So I'll put this IP address here, and the same thing what I can do, I'll go here, and if I want to go on this loopback interface, this one. Okay, so I'll put the reverse route from here also. So IP route. Let me know if you're not able to understand. I'll retry to explain you.
I actually aware about the GRE configuration, so it's quite
Oh,
clear.
Okay, that's
Yeah.
then fine.
I mean, yeah, need to exactly remember each step, but it's yeah, I understand what you're doing. But so basically, you're putting the tunnel destination address from each
Yeah,
perspective. Yeah,
yeah, right. So if
but but isn't it always need to write tunnel 101, like to name it tunnel? If I'm right, it was maybe another iOS. It was possible just to put IP instead. Ah, okay, it's interface plus IP, right?
both we can
So
put, I can put a tunnel or I can put a booth. If you want, I can remove any either, but I just put both.
yeah, so if you're gonna like remove tunnel 101, it's still gonna accept
Yeah, yeah,
configuration, right?
yeah,
Yeah, yeah,
definitely,
yeah, yeah,
definitely.
yeah, yeah, yeah. Okay, yeah. That's
So see, if I should able to, if I should try to ping this, with the source of loop back, we having a source here is like 11.11.11.11.11. The traffic should go over the tunnel, right? Because we created the
mhm,
IP here. So let's see.
yeah.
See, I'm able to ping that. Okay.
Mhm,
Similarly, so my traffic is not going plain routing, not this via. It is going via tunnel
mhm,
because I routed via the tunnel, via the IP route. See that? Next stop is
yeah.
tunnel, not the physical interface. Similarly, if I'll go here and if I'll try to ping this source is 33.33.33.33. See, the traffic is going. If I want to trace route, let's see how the trace is going. Let me see if it is showing general interface or not. Let's wait for a few seconds. Let's see what behavior it is showing. So see, what is IP address showing?
Yeah, tunnel interface.
So it's confirmed my traffic is passing through the tunnel. So my GRE tunnel is up and working. Make sense?
But yeah, but it's next hop tunnel interface. It's not out.
Yeah,
Uh,
it is
yeah.
not taking any of the interface. It is not taking any of the interface. See that? Okay, let me trace another IP address. Might be we having another IP address loopback 1. Okay, we can understand the
Mhm,
behavior. For which we are not doing any tunneling routing, right? So let me trace from this
mhm,
IP address from here. Okay,
mhm,
we can understand. So .1. It should go via this, from this to this to this, not via tunnel. Let's
mhm.
see. See,
Yeah. But this hop is local interface IP or next
next stop. See next stop.
next
23.
hop. Yeah. Mhm,
23. So it is going
yeah.
via ISP, the internet,
Yeah.
not via tunnel. Okay. So you can see it is go via this, and this.
Yeah.
But when we do a tunnel, it was going with the tunnel traffic.
Yeah.
So we make sure our tunnel is up and working, right?
Mhm,
Now we having a two type of tunnel in the GRE, not GRE IPsec. Let me discuss later that part. Okay. So the first part we completed, we build a GRE tunnel. The second part we have to do, we have to build a IPsec tunnel on these routers. So in IPsec, we having a two phases. Okay. The first phase is a ICKMP, ISA KMP, that
mhm,
is phase 1. And another phase we having that ISA KMP phase 2, that is IPsec phase. So we do the configuration phase wise, IPsec 1 phase, IPsec 2 phase. And in IPsec, we having a two mode, tunnel mode, that is a transport, and that another is a tunnel mode. So we need to understand these mode differences. Do you know about that? Do you have any basic idea?
Yeah, a bit different encapsulation. One of them
Yeah.
encapsulate the whole packet, another one, but not very deep with the details.
Okay.
So
Let me
just review. Yeah.
let me tell you. Transport. When we talk about the transport payload, it's only encrypt the payload. Okay. It's only encrypt the payload. IP header will be not encrypted in transport mode. Okay. Clear?
Okay. Mm-hmm.
But when we talk about a tunnel mode, it includes the original packet, including the IP header and the payload, both. Then it additionally add a new IP header. You understand this point?
Yeah, but I'm talking the payload is basically, if we're looking for from GRE perspective, what is the GRE? Like if we have a tunnel, right? GRE tunnel, on the top of it, we're building IPsec,
Right.
right?
Right.
So GRE packet is IP header plus payload. This is a GRE, right? Or what we are calling them?
We are talking about IPsec modes, tunnel mode, IPsec tunnel mode.
Yeah. But when we put it in the traffic, so basically what we are doing, we again encapsulating GRE.
Yeah, definitely. We have
packet.
to add another header, that GRE header, or like not GRE header. Sorry, actually this is not GRE header. Actually, the packet will created a GRE from source to destination. When it come to the GRE tunnel, it will be encapsulated by over this what I can say IPsec header, either tunnel or transport. Let me tell you. I know you're a bit confused.
So yeah, because two encapsulation happens, right?
Yeah.
One is GRE, another
okay.
is IPsec, right?
GRE and IPsec. Okay. So your original packet will come, okay, and that will having a source IP plus destination IP, right? Packet land to the GRE tunnel. So GRE will add their encapsulation, right? Encapsulation on this packet. Now we are going to apply tunnel protection with the help of IPsec on this GRE. So then this complete packet will become, one packet, and over that we are going to apply the IPsec headers, and then we are going to encrypt that.
So basically first encapsulated in the GRE and then encapsulated in the IPsec. But when we have those two models, transport and tunnel, so when we are encapsulating the GRE packet in the transport, so IPsec header is visible, right?
Yeah,
When
right.
we
Transport.
encapsulate,
But when we going to tunnel, that IPsec header also will be encrypted along with the payload, and additional new header will be added for IPsec and tunnel, like IPsec tunnel. New IP header will be added. Not clear again?
So about those two modes, like so about those two modes, the difference is one let's review again the tunnel mode, transport mode, right? So
Payload, then IP header. Okay.
yeah,
And add IP header again here. So we will encrypt this part. That will become a tunnel mode. When we having this packet, we having IP header here, and this is the payload. We are encrypting this part only. that become a transport mode.
And the payload is actually GRE packet, right?
Yes, yes. Whatever the packet we are receiving originating actually from the GRE from the user machine, that all become a payload.
Yeah. Yeah. So why need to do IP headers actually? Like we adding to the GRE header, if I'm talking about the tunnel mode, we adding IP header, then we encrypt it, and to transfer it, we need one more IP header, right? What's the difference? Where we can use one or another, because basically looks, yeah, I cannot imagine how it applies. What's the difference? Like in one place we have a 2 times IP header on the top visible one and another inside encrypted.
So
Right.
the only like in production environment, like if you want to make secure your environment in term of the transport and tunnel, then what is happening here, like you original packet you are in, like whatever information you are sending from your source to destination, that IP and packet as nobody can see what inside of the packet, but the header can be read by anyone, that
Yeah.
additional header. So that providing the additional security here in the transport, tunnel mode configuration. But when you are talking about that transport mode, it is still secure, but their IP address can be exposed. Actual LAN IP address can be exposed. So hacker can know that what is the from which LAN this packet is coming. So there might be chance for some malicious traffic can be sent to the LAN, and they can try to do some malicious stuff. So that is
Okay.
only
Yeah.
security per point of view for the transport internal mode.
Basically not to identify from where it to where it's sending,
Yeah,
because yeah, so anyway we're not gonna see a payload, but if we use a transfer mode, so if we capturing packets, we can at least see source and destination, and then we
yeah.
can look forward to those source and destinations. And yeah, okay, yeah.
If we talk about
Mhm,
tunnel mode, then definitely nobody can going to see that. There is a dummy IP address added on the top of that for just communication. Okay.
okay, yeah, that's clear. Thanks.
All right. So next we having a task to just configure this IPsec phase 1 and phase 2, what I discussed right now. So let's quickly go and configure that. Okay. And then we'll see how the configuration is going to be happen. So I'll go on the router again, and I'll go in the configuration T, and step-by-step configuration we have to do. So we are doing the ICMP, ISA KMP phase 1 configuration. Okay. So I have to create one crypto map. So you can just recall or write that command if you're not aware. If you're aware, that's fine for me. Okay. So we have to just while defining the phase 1, we have to create the crypto policy where we have to match 3 parameters. And that's our mandatory parameter. That one is the encryption type. Encryption type. Not this. Sorry. That would be the what is the encryption, what is the hashing mechanism, right? What is the hashing mechanism we are going to use, and then authentication. These three must be, you have to match while creating the phase 1. If these three, authentication, encryption, and the hashing mechanism will match of the both of them, then your phase 1 will be up. Okay. Phase 1 will be up. And then you have to define sub key and peer address detail. Then we'll see how we define that, and that basically help to form the peer neighborship in IPsec configuration with the help of these three: negotiation and peer IP address and the key. We have to define these all. So let me do the configuration so you can understand. So
in total 4 things supposed to be.
yeah. So let me write that. So first I'll create a ICM sorry, KMP policy. So let me write this policy as a 10. I can give any number. See that 1 to 10,000. So I'll just give in a 10 policy. Then I can like I come in the I say Kempa, mode. I say a KMP mode. So now I have to define encryption. So whatever encryption I'm defining this router, same encryption I have to define on another end. Then this router, then only the negotiation can be happen. So if I am going to see the encryption, so here we having a lot of way of the encryption, that 3DES, AES, and DES, 3-key, triple DES. So these are the encryption type. So here I am just going to select the 3DES as encryption, and then okay. So encryption is done. Now I have to define the hash mechanism. So I'm just going to select any of these hash mechanism, but that should be both from the both ends. So here I'm going to just simple MD5 hashing, and then all. We define the hashing as well. Now we have to define the authentication. So authentication, again, you see that there is a lot of authentication. So I just going to take a pre-shared authentication, and that's all. And I can define some group. Then both can be in same group. So you can see that there is a lot of group like Defi, Hellman, lot of we have a group. So we have to choose any of the group. So I can just choose a Defi Hellman group 2. So let me choose Defi Hellman group 2 and then enter. Then lifetime, if I want to define, I can define. Not, there is no mandatory, but there should be default should be 8640, and that should be both and the same, not like a different. So let me define lifetime also. So I defined the lifetime also. That's all.
Time for tunnel, how long it's gonna be up.
Yeah, definitely. So do show run section crypto. So see, what else we have? I believe I have old configuration. Let me remove that. Or there is some old configuration here. Oh, this is crypto. So let me remove this configuration. Then we'll configure again. This should be not there. Let me remove this also. So no crypto profile. Let me see what else we have. Crypto transformance set. Okay. So run section crypto. Okay, so this is our configuration we have done right now. We remove all the legacy configuration. So we have defined this crypto SMP policy. We have defined the encryption. We have defined the hash, authentication, and group. Okay. Now we define also lifetime, but it is not showing here because this is a default value. I told you, no, this is a default value, so it will not going to display here. If you're going to define some another value, it will going to display here. So that could be the same for the both end. So now in phase 1 also we have to define some one more configuration, like we have to define that crypto ICMP key and the peer address. So we have to define from which to which address I'm going to build this tunnel. So this is my next of peer address, and I've defined some negotiation key here. So I just go in configuration and
We are
right
doing phase 2 now, right?
No, it's still not phase 2. It's still phase 1. I'll tell you when do the phase 1, phase 2.
Okay.
So key, and let's say suppose I put a key as a Cisco. Okay, just we need to remember. And after Cisco, we have to address the peer IP address. So I'll just go and put address, and then I have to define this IP address as a peer 2300.3. So 2300.3. That's all. And netmarks I don't require. I can just put enter with a single IP address. So we have done with the phase 1 configuration.
Now we are done. We described those options: authentication, group hash. What's one more?
Encryption, hashing, authentication, and group and lifetime.
Encryption, yeah, those we described, and then we told the peer where the destination. Peer is actually another end of the link, right?
Yeah, right.
Yeah.
So let me copy paste this configuration on this router, the same configuration. Okay.
Yeah.
And enable and configuration. Why not I'm able to do copy paste? This is the major problem. See, I'm copy this, but not able to paste here. Okay, so let me crypto. Let me write the command. So crypto ICMP policy 10 encryption, like what we have taken 3DS, right? 3DS authentication. We have taken pre-shared hash. We have taken MD5 and group. We have taken 2. Lifetime. We have taken default one, right? Lifetime we have taken default one, and then we exit from this and we just create a crypto crypto ICMP key. We define key as a Cisco, right?
Yeah.
And then address and another peer address would be 12.12.0.1. Okay. 0.1. So that's done. Okay. I believe again we have some legacy configuration. Let me remove that. I forget to erase this router. So run section crypto. Let me remove this configuration. Then we'll test. Okay. So this is the old key. I believe we have put it there, and no crypto transform set. We don't require this one also. We don't require this one also. No. Okay. What happened? So run section crypto. Still one configuration is there. Let me remove this one also. So now we are good. Okay. This much we're done. So let me go in the configuration again. And in configuration, I have to create the crypto key again. So that crypto ICMP key. Then we have to use Cisco address 12.0.0.1. Fine. Then after, let me write this configuration. Okay. Because I don't want to. Oh, what happened? So after writing this configuration, if I'll go and check the phase 1, so see crypto ICMP SA, it is nothing showing right now. Okay.
Okay, SA source address.
Yeah, security association, not source address. So there is no security association. Okay. So let me show crypto ICMP SA. So let me check from there also. So there is no security association right now, right? So let me, yeah.
Yeah, security. So basically we configured both sides.
Yeah, phase one we configure the both side, but there is no still. Yeah, I still have to configure the phase 2. Then we'll check what is happening. Okay.
Yeah. Okay.
So we have to create a phase 2. Then we have to go in the configuration and we have to create one crypto map IPsec. This is the phase 2 when we write the IPsec, and then we have to get one transform set that is going to apply over the some crypto map, and then crypto map is going to apply for the tunnel. So we'll create a transform set like GRE over IPsec. We can write a name GRE over IPsec, and then we have to define from this as a what we can do authentication, like encryption type of this different encryption we having for the IPsec transform set. So we can choose any of this. So let me choose ESP3DS for this one again. So it's similar to that encryption what we choose earlier. And we also have to select for the authentication hashing mechanism authentication, that is again for the ESP-MD5 HMAC. So we create that, and here we have to define that tunnel should be transport or tunnel. You can see that.
Yeah.
So if we select the transport, payload encapsulated, right?
Yeah.
Where we get datagram encapsulated mode, complete packet. So let me select the transport only here, and that's all. So we completed transport set here. Then
So
we have, yeah,
tunnel. So tunnel mode encapsulate the
payload only, payload, not
yeah.
IP header. And in
Okay, and that
it-
the tunnel is more secure. It's
yeah,
encapsulate. Yeah. Okay.
yeah.
Oh.
Crypto. Oh,
Do
I
show
believe.
run.
Yeah, do show run section crypto. So we configure this, and then after we have to quickly go and crypto IPsec. We have to create one crypto map profile. Then I have write a profile, and let me write GRE protect, whatever I can write. We are just protecting the GREs. I just write a GRE protect and set security association. We have to define sub security association and its negotiation value. So let me see what is the lifetime we have. And then again, I have defined 80. Wow, how was the value? 86 for, I believe,
Yeah.
100. That were default, right?
I think so. Yeah.
I think in second, I believe in we have to define in second. 86. Let me check. Yeah, it is taken in second. So we define the security association again here, the same what we define over that. And that we have to define set transform set, what we define above. What is the transport set name? That is this one is a transform set name. So let me write that and enter. So let me see. We'll review what we have done. So run section crypto. So we can see what we have done for phase one. We define this ICMP policy. In this, we match the three different encryption, hashing, authentication, and group. And we just define one of the ICMP key and peer address. Then we created one of the transform set for IPsec phase 2. And we have defined here that encryption type and the hashing mechanism. The same thing, what we have defined here. But it's a more, advanced kind of the stuff. And then we define the tunnel IPsec mode should be tunnel or transport. So here we define the transport. Okay. Then we create one crypto IPsec profile and we add the security association lifetime second, and then we call the transform set what we created. Now the final step we have to do, we have to go on tunnel, interface tunnel, what we created 101, and we have to call this, tunnel protection, what we call IPsec, and then we have to apply that profile, what we created, that profile is a GRE protect. So that's all. So we created one end configuration. You can see that IPsec on. Now quickly have to go another end, and we have to configure that phase 2 configuration again here. So we have to create again that crypto IPsec transform set. Okay, you have to remember transform set. Then we have to put the name of transport set, that is a GRE over IPsec. That was the same name we have taken.
It was without dash. You made a
Oh,
space there. Yeah.
oh, there is some issue. Uh,
But how it accepted the
let me,
name, I don't
let,
understand it. If you make a gap.
okay. So let me create this one as it is. Okay. Okay. IPsec and not accepting here, right?
Yeah, but
IP.
how there was accepted? I was looking at it and I thought, yeah, maybe it's IPsec as a command, but it's a name, right?
Okay, let me complete here. Then we'll go and check character. Right? Okay. So we have to ESP3 dash. Then we have to define that MD5 also, right? So where the MD5?
Yeah. Yeah.
This one is the MD5. So we define this MD5. Then okay. Then we have to define the security. Secure. What is set security
Mode.
association? Crypto IPsec we define. Oh, sorry. We have to go and define the mode, right?
Yeah.
Yeah, we have to define that transport mode. We
Transport.
define the same word defined, right? Then we have to go and let me check what we have done, what we have pending. Crypto. So we define that phase 1, and for phase 2 we just define the transform set. So now we have to call this transform set under that our profile, like GRE profile, what we're going to apply on the tunnel. So we have to create one GRE profile. So crypto, that IPsec profile we have to create. Profile, what we name put there. Let me check the name.
GRE protect.
Oh, GRE protect. GRE pro.
With the dash. Yeah.
Protect spelling is right. So GRE protect. We create here GRE product, and then after once we create a GRE product, we have to set some security association, right? And we have to define the lifetime in second, and then 86400. That was the same value.
Yeah.
Yes. So same value we have. So I just put that same value and set transform set GRE over IPsec, right? And then we have to go on interface tunnel 101, and we have to apply tunnel protection, right?
Yeah.
Tunnel protection IPsec, and what is our GRE product, right? No, I'm missing something. IPsec transform set, IPsec profile, not transform set. Let me check. Yeah, IPsec profile, and then we have to put this GRE profile. So we not need to define anything else. So let me check what I have done. Crypto. So let's see if I'm done right things. So I just created these 4 parameter mandatory is GRE peer, Cisco key, transform GRE over IPsec, this, and this. Let me go on this router and so run section crypto. So let me first remove this. If I have not removed this, then I will not remove the still not be deleted. Let me go in this and let me remove this IPsec. Okay. Then I have to come out and I have to say no. What happened? Section crypto. Now can be removed, right?
Looks like not accepting to remove.
Why? We remove now this. Let me remove this
Is
crypto
in
also.
use.
Where it is used? Oh, okay. We call this internal, na? Do show run interface tunnel 101. So from there also we have to remove. Okay.
Yeah.
Then only it is going to be come in effect. No tunnel profile. So one mistake kill our lot of time. But still we having a scope of learning, right? Okay, so I just remove this and then after I'll put this again and I'll just put dash here, right? Clear? And then mode would be transport. Then exit and then I'll go and where is the remaining configuration? Where was that? This is the configuration. Let me copy from here. IPsec, right? And then I have to go interface tunnel 101 and then tunnel protection IPsec, then should be profile. And then I have to GRE protect. So that's all. Let me write the configuration and let's do the verification. Quite take time in this lab. So there is some verification command. First we have to check so crypto ICMP SA security association. So you can see that there is some security association here. One is the QM idle that is deleted. Okay, but another is active. So that's fine. So this is confirming we having a security association with this IP address. Okay, from this router R3. So let me check from another router also. So crypto ICMP SA. So here also destination is this IP address. You can see that. And source is this. And QM idle means my phase 1 is up. So this is phase 1 verification. Okay. Now we have to do verification for phase 2. Whether my tunnel is up or not. IPsec. So we have to run some command to verify that phase 2 also. So before going to verify the phase 2, like we need to know where my crypto says, yeah, where my crypto, sorry, you're saying something?
No, just sneezing. Sorry.
Yeah. So crypto session. So you can see that we having a crypto session here and that is up and active with the interface tunnel this. And what is my local IP address? What is my remote IP address? And that what the host basically permit IPsec flow. So this is proving my phase 2 is also up, but we having another
show crypto session, right?
Yeah. So crypto, we having another command for the IPsec SA. So we run ICMP SA earlier for check the phase 2. Okay, that command. So crypto ICMP SA. We check that phase, we see phase 1 is up, right?
Yeah.
Another command we run that this one, so crypto session, where we confirm that phase 2 is also up. But for more detail, whether the packet is going or not, we can run a command, so crypto IPsec security association. So here we can see the more granular detail. You can see how many packet you have sent, how many packet has been received from one into another end. So you can see all saying 002 you, right? But when we initiate the traffic, that should be some hit counts on this packet, encapsulated and decapsulated. Okay.
Okay.
So let's start some tests. So I'll go again here. I'll try to ping 333.33.33.33 with the source 11.11.11.11. So here you can see there is 00 counts everywhere in encryption and decryption. Here also you can see. So crypto IPsec SA. So all packet are 0 here. Nothing is there. Let me run this command, shoot some packet. So I just send a 5 packet. Let me see again here. See, 5 packet encapsulated, 5 packet decapsulated with the help of the IPsec.
Okay.
My tunnel is working fine here. Now see on this router again. See, 5 packets encapsulated, 5 packet decapsulated. What the reply we received. So it's proving my traffic is going with the IPsec tunnel because my packet is encapsulating, decapsulating here. So if I'll say, suppose if I'll ping repeat 20 packets. So let's see, I sent 20 packets. So now hits count should be 25 here. Okay. So see, my packet has been increased. So if you see that your packet is encapsulated but not decapsulated in IPsec troubleshooting, that means you are able to send the packet from this this to this, but somehow it is not replying. So you can troubleshoot on this packet. But if you're saying whatever the packet you are saying that is encapsulated and decapsulated both in, that means you are fine with this configuration. Okay.
Okay. Yeah.
So I'm just writing this configuration. You can do lab by your own. You can check the configuration whenever you get a free time. I believe we covered a lot of things. Yeah.
If I gonna connect to the labs and I gonna actually, I had opened this, but it was dropped if I'm right. So
yeah, you can open, you have a credential now, the same credential what I have. Yeah. You can go and play. You have the admin right. Even you want to do make another lab, you can do by your own, not an issue.
Okay. Okay. Yeah.
Okay. So it was interesting or not?
Yeah, for sure. Now I need to a little bit work on it to harden with the fingers commands because it's a bit yeah, need to put the work